The views expressed in the following show are of the host, the guest, and the callers. The content of the following show, its accuracy, authenticity, and the ramifications of the use or application of said content is the responsibility of those speaking and listening, not the broadcast medium.
All right, we are back, and we're recording live. We tried to do a live broadcast via YouTube, and amazingly, even though I have a huge setup here, it blocked the HD up a live simulcast. So we're recording this locally. It's going to be taped live, as far as no editing and all that. And I'll be uploading it after the interview. It is going out now live on Spreaker, so that is live audio, and it will be archived as well. We have with us today James McCanney, who is he needs a large introduction to show the body of work that he has done, but to most people listening, he doesn't need an introduction because they're well familiar with his work over the years. I've first listened to James on Art Bell and through Coast to Coast years. His website has his books and his writings and his audio radio show he's been doing for years. And that's how I have been keeping up with him. But my favorite thing to say about him was his work on both the Comet Plasma Discharge Model and the Weather Book are my favorites. Because the Weather Book that's available, it's the first time I understand how weather works. I mean, I could literally now have a knowledge of how and why it works, where when you tune into the various weather channels, they're saying, oh, chance of this, chance of that. I can look at the radar, and I can do a better job locally. I mean, and it has to do with understanding how it really works, how tornadoes work. It's all but the electricity involved. And so personally, that's my favorite thing. Though I have to say, in recent years, his work with the prime numbers calculation just split open wide all of the encryption that's been going on and warning about how people can break it and so on. And sure enough, after he released his book, within a year, all these websites are being broken in. It's like they knew some way about it, but him coming up with this book explaining how it works and whatever, it just kind of let the whole world know what's going on. So those have been my personal things. And, of course, the plasma discharge comet model is legendary in having NASA put up all these probes for their giant snowballs and have them all find out, hey, there's no snow there. Hey, it's kind of hot, actually. Wow, there's hydrocarbons there. Well, if they would have been reading James's works, they would have known all of that. But without further ado, let's bring in James McCanney. I appreciate you being here and talking with you. And like I said, in your work, it's quite prodigious. We're actually talking to probably a future Copernicus. I don't mean to be blowing smoke, but it's true. It's true. The work you've done has been fabulous. And welcome to the show.
Well, thanks. It took 300 years for Copernicus' work to become recognized by the Catholic Church, which was the self-appointed curator of knowledge back in the Middle Ages. So are we in for another 3-year hiatus in true knowledge?
We got the internet now, and that helps a lot because this stuff can't be held back.
Right.
And so this stuff is leaking out all over the place. And other places in the world are a little more open and honest and interested in finding truth in science and work and so on. So that also helps as well. But to add to your resume, now you've come up with the wing generator, which I will get we can show parts of the video. I want to get some pictures of it too. That is another breakthrough in how one can harness wind economically. It's scalable. You can make huge ones. You can make small ones. And they're light. They're inexpensive, robust. They're portable. Yet another thing that this could really, really help mankind in that allow us to depend on wind generation for electricity.
Yeah, the wind is the best source of energy on the planet. It's available. It blows day and night, North Pole, South Pole, doesn't matter. And if you look at the circulation patterns on the globe, it's always windy someplace. And so, along with the concept of deriving energy from the wind, not only did I invent something that's very efficient, something that did not exist before, but the method of distributing the energy to the end user is very important. Because in a nutshell, we assume that the power company should control the voltage, a very subtle thing that nobody really thinks about. But there's no reason for the central power company to control the voltage. And they actually do a terrible job of it anyway. I'm sure, James, in your studio, you have a UPS, or many of them possibly, to control the voltage.
Mm-hmm.
Is that true?
Oh, yeah, yeah.
Yeah, so the central power company is already doing a terrible job of doing what they monopolize. That's the reason they can maintain a monopoly, is because they control the voltage. And it never had to be that way. The Tesla grid was designed to be a variable voltage system. And so you're already paying for that voltage control. And so why not take the voltage control out of the hands of the central power company? And then now we can replace the central power company with wing generators, large-scale extraction of energy from the wind, and then distribute it on the grid, and then put the voltage control at the house or the business location.
I'm looking up here while we're talking. I'm trying to get some of your drawings that are coming up here. This was one of the earlier sketches that I saw.
Right.
Showing how it's scalable in its design, where you could make it, you could have it be for a house, or a block, city blocks. You could make it huge, and yet because we got the video. I'll run that if you want because it does show it running, and you can see it's not fast, so it's not going to slice birds in half.
Right. Well, it's very visible also. We've been testing these in the field, and the birds fly around them. The birds can see them.
Yeah, because they're not going by hugely fast, especially if you get the real tall ones. I don't want to not show this. I'm just trying to figure the best way to do this. I'll have, of course, links to this for people to see it. It's not actually working here. I got your website.
Okay, go to my website. There we go. Click on that one. There we go. There we go.
I'm going to go to YouTube so I can get a bigger video of it.
Yeah, make it. There you go.
Welcome, everybody.
Now
this is James McCanney.
See if I can just fast forward to some of these things.
Go way at the beginning. Let the beginning play.
Okay.
Because you'll see an actual working model.
All right, we'll
just
go with
let that.
Welcome, everybody. This is James McCanney
from
from JMCC LLC.
Should I leave the audio on?
I want to talk to you about two of the largest problems in the world, energy and water.
Because people can go there and watch the whole thing.
Yeah.
What we're trying to get to now is, I first begin with this slide talking about energy and water and all the top 10 problems in the world, but they stem from energy and water. And then, okay.
Okay, here we go.
Yeah, there we go. That's okay. Yeah, let it go. Okay, there we go. There's a model. That's a working model of the wing generator, and you can see it spinning in a moderate wind.
Yeah.
But this is a very high torque device, and it's very solid. Okay, now there we're showing a desalination plant.
Yeah, I'm going to fast.
But,
here we go.
There we go. There's go back there. There we go again. There's another picture. Whoops. No, that's a drawing again.
Yeah, let me just stop it.
Just stop right there. We'll talk about that for a minute. And what you see here is something that nobody has figured out ever. As I sat down, and I said, okay, how do we extract energy from the wind? And just to go backwards in time, everybody has seen the 3-blade wind generators out there across the countryside. That's stupid. The wind just blows right through them. They cannot start on their own. The blades on those things weigh 65 tons apiece. The infrastructure that it takes to put one of those together, and then all the equipment is up at the top, where you have to have a big crane and this massive tower to hold it all. And they're also a failure because, well, I just won't even go into all the reasons.
Right.
But what I've got here now, when you look at this, you see the red with the white cover around the outside. And this is, by the way, I have a patent on this, international patent. So I've been a busy person. A lot has gone into this before making it public. But also you see the power head, which is a vertical shaft power head. So this is a relatively small one. But basically, when we get to the big ones, the power station is going to be down on the ground. And so the wing itself does not weigh much. It's fairly light. And it's very efficient at extracting energy from the wind. And so the big equipment is down on the ground. I mean, there's so many advantages to this. It cures all the problems of the three-blade wind generator. And also solar, my estimation is that solar will go the way of the dinosaur because the sun only shines a few hours of the day. So necessarily you have to store energy, and that's why the power companies love solar. They're pushing people to put solar on their houses because it'll never compete with the power company. So anyway, but this, when scaled up, will replace coal, nuclear, and natural gas power plants.
No, when I first saw this, I saw your earlier your drawings, and when I saw this, the first thing that hit me was how inexpensive it is to make this, how light it is, scalable, like you said, but also what a brilliant idea using sails for the fins rather than, fiberglass or what have you. Light, collapsible. I mean, you could take it apart and easily store it if you were going to move it or put it on a trailer, like you said. And if you're making gigantic ones, what a great idea to use fabric.
Yeah, no, it's very it's inexpensive, but the whole issue here is that it scales up, and when you scale them up, they are likewise very lightweight. They're easy to manage. You can stage them from the ground, basically. You don't need having cranes, etc., is always a help. But they're very efficient. And let me just give a simple example. The three-blade wind generator is a terrible idea. And basically, a propeller is a device, it's a physical device, that is not reversible. And so here, that's a good close-up of the wing. And the wing generator up there looking from the front side, that's the wind. Oh, there we go. You can see it moving. There's a little more distant picture. There we go. Yeah, great shot. And very stable, very strong. Where these are located in the test system, they get pounded. I mean, literally, the weather is extreme. And this thing is just a champ. I mean, it's out there just being in brutal weather. There's a picture from a distance on the trailer bed where this one is mounted, so they're portable. You can move them around and set them up. And this one, by the way, is operating some equipment that's about 150 feet away. So there's all kinds of advantages. The power heads are high voltage. Here's for example, right now, this is a dump load, it's called, but it's a way of heating your house directly with wind. That's part of one of the experimental processes that I'm using. But if you had this in your house, you could have a wind generator outside or a large wind generator for the city, and you could heat with electricity from the wind. Beautiful idea. No burning coal, no electricity from nuclear power, strictly from the wind. And here's a distance view of the wing at a moderate wind. And these things create a tremendous amount of torque. So you can directly operate pumps and compressors and other machinery. And I talk about, I put the picture of the jet in there because literally this is bringing in the jet age of wind energy. It's, it's just light years ahead of anything else that's out there.
You also mentioned desalination using this idea. Well, actually, because you're using the wind to power it, it now becomes efficient or feasible because of the use of electricity for it.
Yeah, desalination, and then this is a picture of a atmospheric water generator. I have picked up a line of these. I actually have 2 lines of this product lines, and this extracts water from the air, but they're very power intensive. They take a tremendous amount of power. This one, for example, is 2,500 liters per day, the one in the picture. And it requires 43 kilowatts of power, continuous power, electrical power. Mm. And so what I've done is I'm now able to operate these with the wind, bringing the cost of these. And so now in third world countries where water is a problem and energy, the marriage of these 2 systems brings water and energy to places. Remember, 3.5 billion with a B, 3.5 billion people, of fully 1/2 of the world population, does not have access to electricity and clean water. And so in one fell swoop, I've solved both those problems.
Yeah, that's, I'm trying to, you have another picture here. I'm trying to find it where you were, there you go. There's the model of it turning.
The CAD
and also,
cam.
Notice you can swivel it, so you can turn it to optimize with the wind flow.
Correct. Yeah, and there's different types. Now, this one we're seeing now has the full base that turns, and the one we saw before has a different type of tower and mechanism for mounting the wing. So there's different configurations based on the application, et cetera.
Yeah. I'm kind of just looping around here. So this way, you've solved all the problems associated with it, the cost, the scalability, the weight of it, the environmental problems with chopping up birds and whatnot. And I've seen videos on YouTube where these things catch on fire and fall down and are quite impressive, but it's something that you wouldn't want to do. And I've driven next to these trucks on the road carrying these things, and the blades are just humongous. They have to have the actual generator that they carry out there is so heavy that they have to have trucks that have like 50 axles to be able to carry the thing. And
right, and they break down very readily. The problem is with the 3-blade wind generators, they're very short-lived in the field. And so most of them, and additionally, get this, they have a motor inside to get them started. The wing generator is self-starting in a very moderate wind, probably under 5 kilometers per hour. This starts and begins generating electricity.
Now, is there some mechanism needed so it doesn't spin too fast? I know some of these 3 blades have brakes in there to stop the thing from turning too fast. How does this work in higher winds?
Well, I'll tell you, that's an interesting question, because we can let these run up to extremely high RPM, and they work like a champ. We have ways of limiting for the protection of the electronics. But this thing, we've had it up into 50, 60 mile an hour winds, and it just runs like a champ. Doesn't affect it at all. So there's no need to break this and shut it down because of high wind. It starts at low wind, works through the mid-range and up into high wind speeds. And recently, we've had some in near hurricane force winds, and they're just, brutal conditions. And these things they're very well built, they're very strong, and lightweight. And I'm very impressed when you're out there seeing these conditions, and that thing is just taking it like a champ. It's amazing. Whereas the 3-blade wind generators, they have to shut them down. They don't work at low wind speed, and if it gets over 30 mile an hour wind, they got to break them and shut them down.
Huh. Now, how has the response been? I mean, I understand, like, you're not going to get a call from Westinghouse on this, but as this gets out there, I mean, how is this being received? I mean, especially from outside the U.S., other countries, people who generally want to be able to generate power for their communities, I think would love this idea.
Yeah, it's unfortunately I can't talk publicly now about the negotiations and the dealings that are going on behind the scene. But yeah, it's. Let me just put it this way: there is a sense of desperation out there now that did not exist a couple years ago, and even though people knew there was a problem, now there is a sense of urgency. And it's from the United States, it's from foreign countries, it's from from all over the place. And let me just say, yes, there's a very intense interest in this.
That's good.
Yeah, it's time has come, and the like I say, the design is patented, it's trademarked. There's all of the legal structure behind this is all set up. So. I've been a very busy person, basically managing all this to get it into position where it is stable, not only physically in the construction, but also everything that it takes to manage this as it moves out into the public.
So this particular design kind of looks like, a regular table fan you would have, but as it gets up in size, it would look more like a Ferris wheel in that it wouldn't be rotating on an axis that could, fall off. You're going to have, let's say, bearings on both sides as it turns in the middle, I would imagine, looking from some of the other pictures.
Well, there's a couple ways to do this. And this one has you can see the tower in the back, the 3 posts in the back there. Right. That's the base. And we can make those very big. We can make that structure very large. And you can see now on this picture here that the wing structure in here, instead of having the wings, we just have flat plates just to facilitate the drawings.
Right.
But you can see that the wing generator goes all the way down to the ground.
Right.
It's not just up in the air. And so the interesting thing here is, let's imagine you're a kid and you went out to the playground, and remember those kind of little Ferris wheels that, not a Ferris wheel, but it's like a thing, and everybody pushed and then you jump on and go around.
Right.
Like a merry-go-round type of thing.
Yeah.
And so if you were a little kid and you couldn't push very hard, and there were big kids on there pushing really hard, then you could, everybody was pushing according to their own ability. Is my point. And with the wing generator, it's the same. So you might have the wings up at the top really pulling hard because they're up in a higher wind, and then down on the side or at the bottom, they might not be pulling as hard, but they're all adding to the torque because they're all connected together. You see what I'm saying?
Right, right.
This is one structure, and it's really, really solid. So, and there's a lot of cross bracing. There's a lot of design that goes into making this into a very rigid structure in the wind.
Yeah, and by using cloth, I mean, it makes it a heck of a lot lighter. And then, of course, you could use some type of light fiber carbon or tubular. There's, the sky's the limit as far as as you're playing with it.
Yeah, the picture of the red one with the white shroud, this one here, all that structure is carbon fiber. Mm-hmm. So it's funny, but you pick up this whole thing and it's like light as a feather, so it's you may not see that here, you may not notice that, but it's very lightweight. And when the wind catches it, let me tell you, the people that have seen this, the one comment that everybody that's familiar with wind generation, et cetera, their one comment is that it doesn't make any noise. There's no vibration. There's no electrical noise. It's silent. And you listen to it, you can hear the wind, blowing through your ears, but this does not make any noise. And so it's a very interesting system.
It is. It is. Here we talked about some of the other things you've done, which would be more intellectual. Let's say the Cosma plasma discharge, Cosma, the Comet plasma discharge model. That's kind of an intellectual thing, explaining how things work. And even the weather, it's understanding things and so on. But this is actually a practical application that can be brought down into space-time continuums to raise the quality of life. This could be the most practical of all your work in terms of helping humanity on a global scale, a huge scale.
Yeah, this is something that, and when you couple it with the ability to create water from the air, this is an enormous step forward. So, and if you're talking about 50% of the world population, in 10 years, this could revolutionize the socioeconomic situation in the world.
Yeah, because you could, you can go into areas. I mean, I remember seeing the little, looks like a coffee maker that could sit in your counter that will pull the water out of the air. I remember seeing those little things, and it would take a long time to make a few quarts, and you're plugging it in the wall and all that. When you got this size, being powered by its own power plant, that is phenomenal.
Yeah. This is there's a lot of interest, or like we were looking at the resistor bank for just creating electricity and then changing it into heat. So you could heat houses, you could have processes. This right here is what I'm talking about. This is a 3-phase resistor load, and basically you could heat your house with this. This would take the place of your furnace. And for storage, you could imagine building a cement room below ground off the side of your house, having this resistor bank in there. You're heating up the cement, and then you simply blow air with an air exchange into your house. So you could have hot air heat, and you could heat up this cement room to a very high temperature, and that's a way of storing the energy. And then when you need heat, you just open up the vent, and this could be done automatically, and just run the warm air into the house. Or you could run these as baseboard heaters, electric baseboard heaters in a house. So either way, but there's, I won't say which country, but there's a country that's very interested in this because it's a colder country, and where they have plenty of wind. So it's a way of basically free heating, without burning fuel oil or natural gas or nuclear power and creating electricity. It's a way of basically heating those houses without burning high octane inert materials.
Yeah, it's interesting. This technology, this heater, plus the water generator, is inefficient in terms of what it costs to plug it in the wall to use. Right. But now having the power coming, if I could use the term almost free, once the structure is built, your power is coming out of the wind, these now become desirable. So it's kind of like taking this, your wind generator takes, let's call it older technology, and bumps it up right up to the front of the line.
Right. Exactly. Yeah. And this is just a few of the applications. This brings all types of applications that were previously hindered. And for example, let me bring you an example. Mining. If you have a mine that's underground, then typically you don't want gasoline or petroleum. Their electric bills are huge because everything has to be done with electric. They use compressed air, et cetera, because there's very low risk of explosion, but you can't have fumes or oxygen burning down in an underground mine. So they have a tremendous electric bill. So if you can reduce the electric bill in mining, now you can open up mines that were not feasible before.
Let me just see if I can. I'm looking at this to get past the little introductions here. Commercials here. I got to get rid of. Here we go. I want to go to this to show some of the failures. How about this?
Oh.
How about this one? It wasn't even turning. It just fell over. That's quite impressive.
Ooh, ouch. Yeah, there's YouTube is full of videos of failing 3-blade wind generators.
Yeah. Because
some of them are pretty
I don't know, is it going to hit the bird? I don't particularly like to see that. But let me see if I got there's one where it was actually on fire. That was a little scary.
Oh no.
It hit the bird. Darn it. I was trying to avoid that.
I'll tell you, James, the other day I was out at one of the sites of one of the look at that. At one of the wing generation sites, the test sites. Oh, this one, I can tell you what's going to happen with this one.
That's why I mentioned about the speed of it, because...
Yeah. No, the wing generator will do that and more. And it'll just walk through it like nothing. Ooh. There's $1 million, $2 million bucks down the hatch.
Yeah, and hopefully there's no farmer walking around doing his field.
Yeah, no kidding.
Getting hit by this stuff.
No, we've had the wing blowing in tremendous winds, and it just look at that thing go up in flames. Well, see, now that's the other thing with the wing is all the heavy equipment is on the ground. There you have all the heavy equipment up in the air.
Yeah.
Ooh.
You see how slow they're falling down? It's because these things are huge.
These are big. Yes, they're very big. And the wing generator will be big also.
Right, but as you mentioned, the design of it is you have the the system that's up in the air is not, it's not like the heavy motors and everything up on the air. It's on the ground. So
right.
In the unlikely event that this would somehow dislodge, it would be quite less of a problem to repair and whatnot. Right.
There's other safety features too that on the bigger ones we'll have breakaway sails. We'll have things like that so that if it really, hurricane force winds or something like that, there's fail-safe. There's a bunch of backup fail-safe systems.
I just like watching it.
Well, that's why I say that this is bringing in the jet age of wind energy, because it's works on the same principles as a jet engine.
Right.
By the way, it has the same simplicity as a jet engine. The only moving parts on this are bearings. The only moving parts, and so there's nothing to break. If you look at the 3-blade wind generator, they have immense amounts of moving parts in control systems and yaw and pitch and change the blade direction and transmission that goes from low RPM to high RPM and just all this equipment. And so the electronics and everything that goes with the wing generator was designed for the way it works. Very simple. If you look at it, the only moving parts are bearings. Very reliable.
I'm just checking to see if I... Okay. Yeah, this is... Well, I really hope this takes off. I know you're dedicated with this to help the world, and you're not holding the world hostage or using political power to, you're just saying, here it is, and you're trying to get it out there. So I'm really hoping that it happens. And what you need, I think, is probably some places outside this country, frankly, to really start using this, and that'll be the salesman for it, to see, or perhaps even having some industrial parks who want to have wind power or offset some of their electricity, putting some of these up there. That'll be a nice example.
Well, like I said, the sense of urgency is there now. And yeah, it would be in foreign countries. It would be in, certain applications where it doesn't say endanger the monopoly of the Central Power Company in the United States. And so once these certain applications get underway, and remember that in a lot of places in the third world, they are desperate. They realize that they cannot continue doing what they're doing. And so once this is installed, once it's visible and people see it working, it's like this. It's a question of economics, because now if you have a third world country that can produce a product much less expensively because energy is not a cost, is not a factor, then it creates a demand in the more developed countries to do the same thing, because how are they going to compete against low cost energy? Most industries, their biggest expense is energy.
Here's another nice picture for you.
Oh, I love these. Yeah, sometimes I go to YouTube and just put wind generator failures, and you get some. Yeah, look at that.
Gives you the idea of the.
Yes, this. Yeah, look at that, man.
I mean, just think about the engineering. Is it that the actual center of gravity, if you will, the weight is right up at top?
All of that weight is up there, tons and tons and tons. Those blades will typically weigh 65 tons each.
I've had to actually deliver parts for some of these with my truck. Oh, that's not pretty. Hello.
Little problem there on the way to work, honey.
Yeah.
I had this 3-blade wind generator blade come through the front of my truck.
Yeah, well.
Anyway, yeah, there's a lot of those. But
well, I'm